Hey everyone, this is Jesse from GameDash. This video is a brief overview on how to create an SDK module, specifically a service module. A service module is used to provide support for a game or application so it can be run using GameDash. Because of the way the SDK has been built, you can fully customize how GameDash handles the application. The SDK is fully cross-platform, meaning that any SDK modules that you write will work on any platform that GameDash currently supports, that being Windows and most Linux distros, with a few platform-specific functions here and there. The SDK is version backwards compatible, meaning that unlike other panels on the market, you do not have to re-implement your custom code every time GameDash is updated. We've built in a compatibility layer so we can easily manage the way in which GameDash and SDK modules communicate. The full SDK module reference is on gamedash.io. It lists all the available functions and classes. So let's jump into the code. Every SDK module must have a properties.json file. This file defines the base properties of the module, such as title, description, and offer, but also resources that are available and some settings depending on the type of SDK module that you're writing. The full spec is on our website. In this video, we'll be creating an ARMA-free module from scratch. The metadata in this file, such as title, offer, and description, will only be relevant once you publish the module to the GameDash SDK module repository. It's good practice to always define these anyway for the sake of organization. So let's create our first SDK module resource. That being the setup resource. And this resource basically handles the lifecycle of an instance and has functions that are triggered whenever an instance is installed or uninstalled. So an important thing to note is that every SDK module resource needs to live under a certain namespace. For all SDK modules, that is at least GameDash SDK module implementation, and then the type of module, that being service, and then the name of the module ARMA3, and then the directory path. So that's resources setup for us. Now this class needs to know what instance we're talking about. So we can make that available to all the functions in this class by defining a class property called instance, and then assigning that class property with the value of that instance. So we'll go ahead and fetch that instance with the get method. And every SDK module resource is instantiated with the gateway parameter. And this gateway parameter is able to pass in outside parameters such as the instance ID. So we'll go ahead and fetch that from the gateway. We can do that using the get parameters function, and then get instance.id get value. And for each service module, the instance.id parameter is available. So great, we know now the class knows what instance we're talking about, so we can go ahead and define the install function. So the set of parameters for this instance are passed in through the parameters parameter in the install function here. And depending on the parameters you define in the get install parameters function, values will be present in the install function. So let's go ahead and define what parameters we need set. So for us, we obviously want to know how many slots every server is set up with. So we'll go ahead and define a parameter. And it's a numeric parameter. And we'll call it max connected clients with a title of max connected clients. Okay, so we now know that the max connected clients is available through the parameters parameter. So we'll go ahead and pull that. There we go. So next step is defining a disk quota, because you obviously don't want the instance to be able to take up the entire disk. So we'll go ahead and define that. The set size function is using megabytes, and we'll set a quota of 20,000 megabytes, which is 20 gigabytes. Should be more than sufficient. And then we'll go ahead and install the dedicated server package using Steam CMD. So we can call the installer API. Now we need to know the app ID of the ARMA3 dedicated server package. So we'll fire up our favorite web browser. And as you can see, the app ID is listed here, and it's 233780. So we'll go ahead and enter that here, and then call the install function. Okay, next up. Okay, next up we will create the setting for how many players we want on this server. So we'll go ahead and use the max connected clients variable. And we'll create a setting with the same name. So we'll go ahead and move on to the fun bit, which is obviously starting the instance. So we can do that by defining the process SDK module resource. We need to implement or import the instances class, defining the class property. And then we'll go ahead and create a child process. Basically, a child process is a process running as a child of the daemon. And the daemon is running on the node. We'll create a default one, so we don't need to set all the settings ourselves, and we'll generally also detect them. If you need to change some of those settings, you can override them, or you can create a clean child process where you have to configure it yourself. So we can now set the executable, and we need to know how Arma is started. So we'll go ahead and take a look at the wiki. So we have the Linux start command here. So it's launching the Arma 3 server binary. So we'll go ahead and use that. Set executable Arma 3 server. Then we'll go ahead and set the process args. And we'll get the name of the instance. And then we'll go ahead and specify the config parameter. You can either have the user decide which config to use by creating a setting, or we can just hard code it. And in our case, for the sake of this example, we'll hard code a value. So all there's left to do is start it, and we'll spawn a new child process. Now we obviously need to be able to stop the child process. So we'll retrieve the child process again. We have a convenient function called getCurrent. So it will retrieve the child process based on the ID. Stop. And in some cases, this can throw a child process not running exception. In case the child process has exited whilst we're executing the stop function. So we'll wrap this in a exception handler. Catch child process not found exception. There we go. And we'll just ignore it. Right. We don't need to do anything special during the restart, but we do need to know when a instance is online. So we'll go ahead and check if the process has an ID, because obviously if it doesn't have an ID, it can't be online. And then we'll go ahead and wrap this in the same exception handler. Well, then we'll try to retrieve the status of the child process. So we'll go ahead and check that up directly with the node. So we'll get the node using this function. Get processes, get child processes, get instance, get process, get ID. And then we'll check if it has exited yet. And if it hasn't, that means it's still running. So we'll inverse this because we're asking whether the instance is still online. So that's all there is to it to create your own SDK modules. We'll create another video on how to install your own custom SDK modules or how to install modules that are available via the official repository. But thank you for watching, and I hope this helped.